Okay, this is number 4 on section 15.4. We've got 10 men there. They participate in an exercise program and they measure their waistlines before and after. And they want to see if the waistline, the median waistline, decreases at a level of 0.01 significance, right? 1% significance. So we're just going to load this data up into into StatCrunch and go to non-parametric statistics. Non-parametrics, right? And we want the Wilcox signed ranks, right? These are paired. And the before in 1 and the after in 2. And we want the medians to see if the median difference decreases, right? The median difference decreases. So we compute that. And we find the p-value is 95.18. I made a mistake here actually because I wanted to show you the before minus the after inches. We're not expecting that difference to be negative if the waistlines decrease. I actually did this when I was rehearsing the problem and just making sure I could solve it. I did this myself, so I wanted to make sure you guys saw it as well. If you're expecting the after inches after the workouts to be less than before, right? Then subtracting before minus after will give you positive. Yet we've done a hypothesis test where the difference of the medians would be less than 0. So you got to do one thing or the other. You either got to make the median, the alternate hypothesis, the difference is greater than 0, or you have to reverse the order of the after and before. Okay, so I bet that tricked a lot of people up on this problem. So I'm going to do the second thing I said, just reverse the order. Okay, and now we get a p-value of 6%, right? Which is greater than the 1% level of significance. Therefore, we're not going to reject the null hypothesis on this problem. The second challenge on this problem is that we've got all this critical value language here, which is a different way to do hypothesis testing. And I'll try to explain that really quickly. So first, there's not sufficient indicate the exercise program is effective in reducing waistlines. So we just want to get rid of the two is's, right? It should either be A or C because both of it we're not rejecting the null hypothesis. The only difference between the two is since the test statistic is less than the critical value, and since the test statistic is greater than the critical value. So what I wanted to show you, we've got a left-tailed hypothesis test. And because we've got fancy computers, right, we just always use the p-value and see if the p-value is less than the significance. If it is, then we reject the null hypothesis. If it isn't, we don't reject. Okay, but there's another way to do this. And this is just a distribution, normal distribution, but it could be for any different distribution. There's the area under the curve is the percentage, right, associated with your sample, okay? And so we want to see if the percentage of our sample is less than 1%. And in that sense, we'll just reject the null hypothesis. If it's greater, right, then we're not going to reject. But for each percentage, there's a value on the bottom of the distribution that is associated with it, and that's called the critical value. Okay, so for a left-tailed hypothesis test, you want to see if the critical value is less, or if the sample has a value that's less than the critical value. Okay, if it's greater, then you don't reject. The opposite would happen if it was a right-tailed test. Okay, so that's kind of how you make. So that means A is going to be our answer here.